Live. Okay. Uh, so, hey everyone. Uh, Hopefully people will start joining pretty soon. Um, I'm Eyal, and I'm here with Paul Carter from WaveSequencer. How are
Hey,
you,
how's it
Paul?
going? I'm good. How are you?
Let's put you on screen for a second. Let me maybe I'll do something like put the screen. Yeah, let me turn off your screen share for a second. Oh, here you are, full
Full
on display.
slow-mo.
Yeah. So hey, I wanted to I wanted to bring you on here for a while. You make amazing products and amazing,
As do
really
you.
important product like the Hyperion synth. And I thought this would be like a good chance for us to talk about it, talk about your process of doing this, which is quite insane because you're one of the only people I think ever that made a modular synthesizer yourself, right?
Yeah, it's insane. But I would caveat that with the fact that I started learning about Juice and how to make a modular synthesizer a long time ago. In the sense that I did something similar for Intel, not the same, but similar. And I was very lucky that I got an introduction to Juice from a guy called Matt Titel. He basically showed me how to use Producer, create the most basic plugin that receives MIDI notes and spits out a sound. And this was after I'd struggled with Juice for a few weeks, and I'd got very excited just to make a sine wave come out of Juice, out of a basic plugin. But he basically sort of helped me to make a template project where I had buffer configuration and sort of basic setup with MIDI input to drive notes to generate some tones. And he also helped us to do some work to bring eventually, my sound engine. I developed it further at Intel, and we brought it over into Unity, and that's something that Matt had done as well. He'd made a Unity plugin version of Helm, so we made a kind of a headless plugin based on the code that I'd been developing, and brought it into Unity, which was what we basically did at Intel. We were doing interactive audio visuals, and we would run a synthesizer in Unity to do interactive audio patches that responded to virtual inputs from a camera. So I'm actually using a RealSense camera today, but normally these cameras are designed to take to make a depth sensing image, which is actually a black and white image, and the brighter spots are kind of the closer parts of your hand if you've got your hand in the way of the camera, and the darker spots are things further in the background. And so you can use that to track movements, and we would use multiple cameras and big LCD panels and drive a Unity 3D scene, and use the cameras to modulate the graphics and the sound. So the whole idea of the modular synth was actually, you can blame it on my boss at the time, Ryan. He wanted a modular synth because he wanted to have lots of flexibility in terms of these 3D scenes that we were developing for Intel's lobby and trade show experiences. So he wanted to be able to have something that would be completely reconfigurable. So that was, I think, maybe now it's nearly 6 years ago now that we started on that. And I just sort of started on the very basic concepts of how am I going to define a processing node that could be connected to another processing node. And this was something I scratched my head about for a long time, just to how do you design C++ code, sorry, that's modular in its nature and allows you to pass audio from one node to the next and connect control signals from one node to another. And so I worked all of that kind of piping kind of work. I worked all of that stuff out whilst I was at Intel, figured out how to do that. And when I needed to leave Intel, I was given notice from the advertising agency, even though I didn't actually leave Intel at that time. We were all given notice. The advertising agency was closed, And at that time I thought, well, yeah, I should probably make the most of everything I've learned and develop a plugin. And I thought, well, what do I know? I know how to make modular nodes, and I've got some basics in Juice GUI. So I started developing Hyperion at that point. And I actually stayed at Intel for a few more years after that. And but only recently started turning it into a full-time business. And that was about a year after Hyperion was commercially released.
Awesome. So let's see Hyperion. Do you have it on screen? Let me bring your screen.
Yep, you can share it.
Yeah. So this is Hyperion. This is one of the most advanced modular synthesizers I think that exists. It's pretty incredible. Why don't you walk us through what does it mean to have a patch?
Let's take a look. So one of the unique things about Hyperion is probably that it's not just one modular synth, there's actually 16 modular synths. So right now we've got 4 modular synths, and the idea, it's a little bit like workstation keyboards where you have this concept of patches and then combi patches, and each of these tabs on the left here are actually a separate modular synthesizer, and they each process on their own channel. They could be on an independent MIDI channel. Here you can pick the input MIDI channel, or they can all be on the same MIDI channel and they can be layered. And then you have this graph space in the center of the screen here. So for each of these, you can see the patch changes. And if I just open a new one, we can have up to 16 of these, by the way. You start with an empty graph with no nodes, no sound processing, and originally the background was just this kind of horrible grid, but I've just recently added all these nice backdrop images, so you can pick a nice picture to start making your patch. and then you have this menu that pops up where you can select nodes, and there's lots of nodes, many different categories of nodes, but there's also filtered lists, so you can find a specific type. And the concept is that nodes are broken down into 3 main categories. You've got data generator nodes, you've got audio per voice processing nodes, you've also got FX bus nodes. So let's maybe if I just solo this part, we can just start with a basic thing here. So a voice generator would be an oscillator of some kind, and there are multiple types, but I'll just start with a stereo oscillator. And then we need an audio output node in any patch. And so this is basically the very most basic patch you could ever have. And by default the level's turned down, but if I turn it up, you should be able to hear a sine wave. Do you hear that?
Yeah, and you can turn it down a little bit. And so just so that I understand, now basically we have a sine wave that runs with no connection to any envelope and to the no amplitude envelope connected to the keys. It's basically just a flat continuous sine wave, right?
And this is a mono patch at the moment because we've got no concept of MIDI input. But so I was talking about data nodes. So data nodes are both math processing nodes, but also things like envelopes, LFOs, and various mathematical functions and binary logic that's available here. But if you wanted to make a synth patch, rather than something that's generating a continual sound, you would have an envelope, and you would control the audio output with that envelope. And you see now that I've connected up the level input here, I should take a step back here. So every node is these kind of rectangular boxes you see on the screen. And what you see at the top, I'm calling them pins. The top of these nodes, you've got these input pins. So these are all inputs. And at the bottom, you've got output pins. So the blue pins are audio and the orange pins are data. So here I've connected an envelope node to the audio output input level pin. And so that's a data connection. And an envelope doesn't do anything on its own unless you trigger it. So we could trigger it with an LFO, for example, but typically I like to play keyboard. I'm a keyboard player. So, you know, I like to use notes input to drive my sounds. So here we have the notes input node. This is quite a complex node. It's got a lot of options in it. As you'll also notice, every time I click on a node, it will open a panel on the right-hand side here. Can you see those panels?
Yeah.
So I can control things like the number of voices that we have, pitch bend ranges, various drift parameters, portamento, vibrato, MPE modes, lots of different things, voice priority modes. Those all affect what comes out of the output pins here. And maybe one of the most important output pins is the frequency output. That gives me the note frequency, and you can see if I start dragging a cable from that pin, the pin on the oscillator is actually highlighted. You can see that's kind of slightly brighter, and that's the frequency input pin to the oscillator. So of course we need the oscillator to know what frequency of the note you're playing is, and then you also have a trigger output pin here, and you can see as soon as I start dragging a cable, you can see these trigger input pins get highlighted. But the one I'm interested in is the envelope
Trigger.
or the ADSR.
So it's a trigger for the ADSR, right?
So everything doesn't work unless you patch it up. This is, you know, if you don't put the trigger input in, nothing will happen to the ADSR. It's not a magical, invisible connection. Everything you see is what you get, basically. So what you see is what you get interface.
Okay.
Apart from, you know, there are some features within nodes, like say vibrato here, inside the notes input node, which will actually modulate the frequency output of the frequency output of the notes input node pin here. But generally speaking, you need to connect things up to make things happen. So now if I hit keys, it's pretty quiet.
Yeah, bring it up.
And that's also partly because the level is set to quite low. So can you hear that?
Yep.
And you can probably also see on the bottom left of the screen here the pulses that are coming in. So this is in the input connections mixer tab here. I've only got one input connected to this pin, and you can see the trigger is basically just a pulse coming in as I hit the keys on my keyboard. And we can also visualize that with a graph directly on the node graph, so we could take a look at that trigger. So you see, so it's basic modular synthesis, and the frequency, if we want to have a look at the data coming out of that frequency output pin, you can see that these are the frequencies of the notes that I'm playing. And sometimes there'll be more than one voice that's listed here with a number next to it, and that's because there's a voice pool, and if you're playing notes and the previous note hasn't finished, then the next note in the voice pool will get assigned the frequency, and it will activate a pulse on that voice on the graph. So you can actually see, if I hold two notes down, you can see two triggers on the graph here. So yeah, that's the most basic kind of patch you would make. Within the nodes, it's a little bit more advanced than some modular synths, like say, I guess like Max MSP, where you might have to define some algorithm within the node yourself, like mathematically, or you might have to design a set of interconnected oscillators to make a different kind of waveform. Here you just directly have some wave shapes that are available to select from a pull down list or from these buttons. So now we have a saw wave, and then you have options you'll find in many classic VA synths like unison detune and stereo spreading. So we can try that. So now we've got some unison detune going, and a width parameter lets you control the stereo spread. And we have things like wave shaping, or wave folding, bit crushing, and oscillator sync. And that's a very simple patch. We've not really done anything yet.
And are all those parameters modulatable?
Yes, anything that's on an input pin is modulatable. So let's just quickly hook up a filter here, because typically a synth patch would have a filter in it. Of course, it's totally up to you what you do. But let's give an example of how to modulate the filter. So that's a great example as a kind of an example of how you modulate something. Here I'm connecting to the trigger forwarding pin of the output of this ADSR. Just forwards the trigger.
So
and if you highlight,
so this is the same trigger from the MIDI notes.
Yeah, and if you hover your mouse, I think I might have turned off the tooltips. Let me see. Okay, let me turn those tooltips back on. So if you hover your mouse, you get these little tooltips that pop up. So you can find out what these different pins do. So the trigger, it says here, envelope trigger, positive edge, min and max, so 0 to 1. So most values in terms of modulations are between 0 to 1 or -1 to +1 in this synthesizer. So the ADSR output will be from 0 to 1, and I'll plug that into filter cutoff. And to hear something with the filter cutoff modulation, we need to turn the filter down. So I've opened up the filter panel, and we will see that the filter cutoff gets modulated, and maybe we'll turn up the decay and you'll hear that a bit more. So now we have a filter being modulated. Similarly, we could add an LFO, and we could modulate the fine-tuning of the oscillator to add a kind of a vibrato effect. And you can see within each of these panels, you can see the active modulations. You can see on that fine-tune input, the knob position is the sort of the default position of the parameter, and then the white bar is actually the input signal. And if I click on that pin, you can see that there's a knob that pops up which gives you a quick access to that control. But also, if you look down on the bottom of the screen here, you can see I've got an 8-voice configuration currently. So I've got 8 lines going up and down, and that represents the value of that parameter for each voice. And you can also see each of these voices are being drawn on the sort of timeline graph to the right of it. And I can control how much of that affects the input by just turning up and down the slider here. And I can also control the curve for how the input is treated. So this is either a linear curve, or it's like more like an exponential curve, or like inversed. And I can flip that upside down so that the polarity gets reversed as well, which is quite useful.
This is so cool that you have this visualization that gives you, both each voice individually and like the layered combination. Like I really like that. I don't think I've seen that in other synthesizers, right? They give you like such clear per voice data.
So sometimes I think my brain works the other way around to the way most people think, and quite often instead of seeing the output of the voices here, what you'll see in a synthesizer is it will show you the modulation value, say for the LFO. It will show the LFO going up and down, but it won't show you how it's affecting the target, which in my mind is more useful. I want to see how it's affecting the target. So I want to know how it's mixing with something else. So if I add another modulation source here, I'll add an MSEG LFO. Now you can see, oops, that's my alarm, excuse me. That's not my wake up alarm, it's my medicine alarm. So I have just added this MSEG LFO where I can draw a curve, and I just opened up this editor by clicking up on this little eye icon here. And now we can blend the two inputs. If I turn up, oh sorry, I actually meant to connect it to the other wanted to connect it to this one so we could see the two LFOs interacting. Okay, so now you can see my MSEG being mixed with my standard LFO. So here you can see if I turn down the MSEG, it won't have so much of an effect. And you can see what happens if I flip the polarity. Now it's going to do the opposite. And likewise I can turn down the gain. But if I connect to the filter, you'll hear something quite different. Yeah, so that's modulation, and you can have up to 16 modulation inputs on each pin, which that's a limitation I put in because I felt like that was a good compromise between flexibility and CPU performance, because when you have a complex node tree like this with multiple layers and many modulation sources, well, the amount of processing builds up, kind of exponentially. So
yes,
I limited it to 16 in terms of reducing memory constraints and processing time for calculating all these modulation inputs. Felt like it was a good number, and it was kind of through testing that I noticed that I never really used more than 8 modulation inputs anyway, and so 16 was probably a good enough number.
And do you have, like, for example, let's say you need more, do you have pins that lets you mix other modulations before? Like, can you have like a summer, like a like a summing node? Yeah,
so if you wanted to, I mean, you can always so this LFO, for example, this MSEG, you could just mix another input into it, so I could control its level here with another LFO.
Yeah.
So now I've got a sine wave LFO controlling the level of my MSEG LFO, and if I click back on the filter pin, you'll see that you should see that for some voices it will decrease the level of that input. Yeah, in terms of data mixing, you could take a node that's designed specifically for mixing data inputs and modulating them. So I could take an input from there and an input from here, and I could open this. Sorry, actually not a panel, that's just some. Yeah, I actually have multiple data mixer nodes. So here's another one with some sliders. So if you wanted to visually see what your data mix was, you could do that. But also in Hyperion, this concept of mixing data is that you could take any number of modulators and hook them up to a pin, and you don't really need a separate mixer node. You can just mix them at the pin itself. The same for audio. So if I added another oscillator here, let's go to voice generators. Let's take a FM and hook that up to the frequency, and the output can go straight into the filter. And here you can see now if I click on the audio input pin, I've got 2 level controls that can balance the So now you're hearing a mix of FM and a saw wave going into a low pass filter. So as I said before, these orange nodes, they're data nodes, they're control nodes. They could be logical nodes as well. And then typically in a synth patch, you would have some effects going on as well. So that's what these green nodes are. And let's just add a reverb node real quick. So as you can see,
wait. So if you have a reverb and you put it somewhere else, will the reverb be per voice automatically if you connect it to? Yeah.
That's what I was about to get onto. So there's this concept of per voice and voice mix. So with these blue nodes here, what you only see one node on the screen, right? You only see one of them.
Mm-hmm.
But because this is an 8 voice patch, like if I click on this pin, you can see there's 8 things going up and down. If I turn up the number of voices, I can now have up to 32. Now you can see I've got 32 lines and 32 modulations going on. That's my max voice count for the synth. I can also turn it down to 1, but I typically use between 8 and 16. That's kind of what I find is good. But those, so that means basically these orange and blue nodes, they're actually, in this case, there are 8 instances of the same node duplicated. So in terms of synth processing, I have a voice graph that represents what you see on the screen, but it's duplicated 8 times for each voice. So for the number of voices you have, the same voice graph is duplicated, but with just slightly different offsets in terms of, say, the frequency or the value of the LFO that's being currently calculated. But when it comes to this audio output node, what it does is it mixes down the audio inputs from all of the voices down into a single stereo output that goes onto the aux, the effects bus basically. So at this point, the reverb is a mix of all the voices. There are also some effects bus nodes that are available as voice processing nodes too. So, for example, we have a comb filter in the effects bus, but I also have the same node available as a voice processor. So that's quite useful because as a voice processor, I can give it an input frequency and it will tune the delay time of the comb filter based on the note frequency input that I give it. So then I can make plucked sounds or bowed sounds using this comb filter set to a high feedback amount and with a very noisy voice source. With a high feedback amount, you'll get this kind of ringing sound that sounds like a plucked string or a bowing sound. And I can show you some examples of sounds like that later if you're interested.
Yeah. So I just want to stop you just because there's been a lot of people joining over the last couple of minutes, and I wanted to say to people who are just watching, we have here Paul Carter, who's the creator of Hyperion synth, which is this amazing modular, he's showing right now. And feel free, if you're watching this on YouTube, Twitch, Facebook, LinkedIn, feel free to just post a question in the comments, and I will be broadcasting this to everyone else in the chat, and of course to show this to Paul. Feel free to ask us questions and to ask mostly Paul questions, I guess. Paul, I'd be interested to ask you, like, from the how do you design something like this so that it will be, so it will scale, because this can scale to like massive patches, right? Like patches could be just insane. How do you create something like this that can scale in terms of the complexity for the user, right? Because like I'm sure your code gets super complex, but also the user's patches can get like ultra complex.
Yeah,
right?
I mean, so I've seen some UIs. If you're talking about like how would you make it potentially easier for somebody to make a much more complex patch, I've seen some UIs that let you zoom in and out of the graph, or that let you combine modules or nodes into a group and then turn that into a smaller box. Personally, I didn't want to go that way. Because I really wanted a kind of what you see is what you get interface. So you don't have anything hidden from the user. What you see is what's really happening on the graph. And I felt like, that's all very well, but once you start abstracting things away, it becomes harder to understand what's going on in a patch. So in terms of the workspace, there is a limited size. I've set it to a fixed pixel resolution, but you can develop some insanely huge patches. You can zoom out in the UI. So if I change the zoom level, you can see the whole patch. If you want to see a really big patch, you can see it by zooming out. But generally, you can just scroll around. And where I felt like it was more useful for complexity is this concept of multiple layers. So already you can make quite a complex sound with just one layer, but you can have up to 16 of these. And that's what allows you to build really complex sounds. And you can even have audio passed from one layer into another layer, and you can have data passed from one layer into another layer. So in some patches, they're actually generative patches. I'll have one layer that just generates generates data, generates notes, and then it sends those notes to another layer that makes the sound.
So
So that's how I scale in terms of patch design complexity.
So, for example, one layer would be like a sequencer or something, and then the other layer would be the synth part, and then you can kind of have the output of one into the other.
Yeah. So, I mean, I'd have to switch patch folders to do that, but let me just go to the standard location for patches, and we'll just look at some generative patches. So this, okay, what I want is okay, here we go. So you can hear immediately it starts playing. I've not done anything. I'm not touching my keyboard. So if we have a look at this patch, you'll see that there's a single layer here which has, let me just turn this right down. It's only got control nodes in it. It's got these orange nodes which are per voice nodes, and these purple nodes which are also data generator nodes, but they send the same data to all voices. And what's happening in this patch is I've got some LFOs that are modulating the inputs to scale generator nodes, and each of these scale generator nodes has got a scale selected from a pull down list. I've predefined some scales, so you've got all of these classic scale types: blues, harmonic, Lydian, Phrygian, etc. And I'm using pentatonic in this patch. And these scale generator nodes, as you modulate the data input here with, say, an LFO, it will cycle through some notes in a scale based on the number of octaves you've set, the transpose setting, and it will then, at the output pins here, it will generate either a frequency or a MIDI note value. And we need to do something with those notes, and I have this other node called a notes sender node, and here you can pick a velocity, a note duration, and you can pick a channel. And in this patch I'm sending the notes to the internal synth channels, so that's why I've got synth channel 2 selected in this particular note sender number 2. But if I wanted to, I could also have a MIDI channel selected, and the difference between the synth channel and the MIDI channel is that the MIDI channel would be another track in your DAW or an external MIDI device. We're running the standalone Hyperion here, so you could actually select a MIDI output here, and I could connect this up to a synthesizer and then send the notes to a hardware synth if I wanted to. But I'm not. I'm sending them to these individual layers, and these are very simple patches, but they are set to different channels. You can see here this sine patch is set to channel 1, and then I've got channel 2 for the bells, and another FM bell patch on channel 3. So those are receiving notes from this generator layer, and they just play forever. I have a sequence of notes of values as well. There's a kind of simple step sequencer built in, and what this step sequencer is doing is it's being triggered by a square wave every so often, and each time it gets triggered it goes to the next step. And what's happening here is this step value is actually like a root note offset. So every so often these scale generators will change their root note. You can see they're taking the output. By the way, when you click on an output or an input pin, it highlights the cables that are connected to that pin, so it's quite easy to see, where they're going to. And you can see that they all lead to these root note pins, which sets an offset for the current root note of the scale. So that's why you're hearing the melody here is changing every so often to a different root note. So that's generative patches. And you can also see some of the automation here on the macro values is also being controlled by that generator layer. So here I've got some macro sender nodes, and in Hyperion it has 8 macros which are door automatable parameters, but you can also automate them from within the patch. So this is one way to send data between different layers. So I can send macro values from one patch, and then I can read them in another patch. So another patch might have a macro receive node. Here's the macro receive node, and if we look at the input of that macro receive output pin 1, you can see it being modulated. If I click on it, you see it's going up and down, and that's because you can see it's following the macro knob here. So let me just stop that for the moment.
No, it was hypnotizing. I love this, like
there's quite a few
music.
Yeah, there's a few others I put in here. Let's have a listen to this one. This is quite fun. This one takes a while to kick off. It doesn't start straight away. So this patch here is the generator patch, and it's basically driving all the other layers, pretty much. It's an FM wave sequence pad, a bass tone, a vocal sound. That's the vocal sound is it sounds like a voice because it's going through a vowel filter, which lets you sweep between, the different vowels, A, E, I, O, U, or a different order depending on the selection here. I've got some wind chime samples. Hyperion can play samples. It's got a sample player node, and those are getting triggered every so often. Yeah, that's another generative patch. I've got quite a few others, but maybe we won't go through them all today.
Those are pretty awesome, though.
And at this moment in time, I'm in the middle of developing. Whoops, not that one. I'm developing some patches for a new patch pack. And that's going to be coming out in a week or two. Turn the sound on. So another thing I didn't mention is that I have arpeggiations built into this plugin. Each layer, you can see, when I click on the layer, you can see there's a tab at the bottom here, which is an arpeggiator and chord processor. And that means each layer can be running an arpeggiator. And also it can take the input note and turn it into a chord if you want it to do that. In this particular patch, I've got one of the layers has got the arpeggiator turned on, and if I play some notes, so you can hear that layer is being arpeggiated, but the other two layers, they're not. They're just actually, that latch doesn't need to be on because it's not, the ARP isn't turned on. But this is just a pad sound, and here's a kind of a pluck sound. I can solo or mute these individual layers. It's very handy when you're doing combi design. Sometimes you just want to audition one or two of the layers together, Just like in a DAW, you can, mute or individually solo or group solo layers together. And each layer you can set the transpose amounts, you can set the volume, you can set the keyboard range and the velocity range. And I just recently added these little buttons at the bottom here. These are filters that let you filter out certain MIDI controllers. So perhaps you have a combi patch where you have a solo sound in the right hand and a pad sound in the left hand, and you want to play a solo and you want to pitch bend your lead solo sound. So what you probably want to do is filter out the pitch bend messages so they don't go to your pad sound. So in this case I've disabled the pitch bend for those two non-arpeggiated layers, and if I play an arpeggiation you heard there that I was pitch bending one of the layers, but the other two layers were not affected by the pitch bend.
Mm-hmm.
So the same thing is the case for the mod wheel, the aftertouch, the expression pedal, and the sustain pedal. So sometimes you want to sustain a pad sound and play some other notes on the top, and you don't want those other notes being sustained.
Yeah.
So that's really handy in terms of building up complex multi-layer sounds. So another thing I didn't talk about already is I talked about the effects bus on each patch. So there's an effects bus here. These green nodes are the effects bus nodes.
I just want to say there was a comment from Bubblegum Nihilist, says such an awesome plugin. I don't know if you can see the comments on screen, Paul.
Where would I see that?
Oh yeah.
Is there a chat? Oh, yeah, okay, cool, cool.
There's a chat, and I'll try to bring up anything that comes up on screen so everyone can see as well.
Yeah, thank you. I appreciate it. It's been a lot of hard work, I have to say.
Yes, it looks like it looks like like a lifetime worth of work, right? Because there's so much. I mean, first of all, one thing that I noticed with your modular that does not exist in many other modulars I've seen is you have all these really high level modules as well, right? Like the.
That's right.
And I think that's something that's missing in a lot of modulars, where sometimes you'll have a lot of these building blocks, and you can make your own high level eventually, but it's very difficult.
Yeah.
And here I think I with Hyperion, I think that there's a really good combination of these utility nodes and like really useful, because even just your oscillator, it's got a bunch of built-in interesting things like the shape and the unison and DQ. Like you don't need to chain a bunch of like low-level stuff, even though those exist already. And
there's another reason for that, and that's because of processing efficiency. So one of the limitations that I have set is that there is no audio rate modulation between nodes, and that's because I just wanted to keep the CPU load as light as I could, and so things are processed on a block basis between nodes. There's an internal block size which is limited in size. It won't get bigger than a certain size because I need to keep the block size to a certain size in order to do fast enough modulations. But internally, I think the modulation only goes up to I don't know what it is actually. It's close to audio. It's like 25 hertz or something like that. But it doesn't go into the audio rate modulation. And that's the reason why I have these more complex nodes. So things like oscillator sync, you don't need to patch another oscillator to do the oscillator sync. Basically, there's a virtual oscillator inside the oscillator that resynchronizes the phase of the oscillator as you're modulating the. You can see if I do it manually. Can you see the trace? Actually, let me just open this window.
Yeah.
So you can see it's actually being modulated by an LFO, and you can see what's happening is that the frequency of the oscillator is going up, but it's getting phase reset by an oscillator that's synced to the main frequency of the oscillator. So yeah, so those kind of audio rate modulations, they happen inside the nodes. The same thing with FM. If you want to do FM, you don't patch it up with multiple oscillators. Basically, there's already an FM node that has a bunch of algorithms where the individual oscillators intermodulate. You know, you've got the operators. So this is a 4-operator FM synth. So you have 3 modulation operators, and then you've got the carrier, which is what I call the D wave. So A, B, C are the modulators, and D is the carrier. And you can set these ratios, and you can set the individual levels, and you can modulate the levels of those operators, and you can control the total amount of FM, which is kind of a global control over these 3 operators. And you can also mix between, there's always 2 outputs on my FM. So I do admit that this isn't the best presentation. I would like to turn this into a little visual sort of node graph of the operators, you know, like you would see on the front panel of a DX7 or whatever synth you use. But these algorithms basically tell you what's going on. So if we look at algorithm number 1 here, operator C is modulating the frequency of operator B, and then operator B and A combined are modulating the carrier frequency. And then at the output, where after the equal sign here you have the carrier wave with its modulation plus operator B in parallel. And you can mix between them using this mix control. So you can mix, so all these algorithms have actually got 2 outputs. So you can get the pure sine wave output of the modulators, or you can get the modulated carrier. And in some cases, because the modulators are modulated by another modulator, then you've got basically 2 FM outputs, which you can mix between. So that's kind of fun.
So cool.
But yes, I do come from an engineering background, and I've tried to make this UI as intuitive as I could, but I will freely admit that you know, there are some things that I could improve in terms of ease of use, and I have done over the years. This has, you know, evolved quite a lot since it first came out, where originally I didn't have these graphics where you could see the oscillator shapes. For example, in the filters, I didn't have a filter curve, so you couldn't see, you know, you couldn't visualize the filter, you only saw the knobs. So now you can really see what's going on here. So with the, say, the split parameter, you can see the cutoff offset is being modulated between the left and the right channels. These are all stereo nodes, by the way. So if I turn this up and down, and then also I've got the filter slope, you can see the cutoff slope changes. Same with resonance.
Can you use Hyperion to make audio processing effects as well?
Yes. So I wanted to sort of touch on that earlier. So if I just play some notes here, you can see, maybe it's difficult to see, there's 2 little level meters on this top layer here. One of them is blue, and that's because I'm sending audio to one of my 4 effects buses that I have within Hyperion, and that audio is then being received in another layer with an aux return. So this aux return is receiving audio on bus 1, and that basically lets me reuse one of the effects. So sometimes when I'm making a patch, I want to sort of optimize the CPU, so I'll reuse, say, like these reverbs are quite expensive. Excuse me, I've got messages coming in. I'll want to reuse one of the reverbs in one patch, in one layer, and use it in a different layer. So here in this layer, there's no reverb actually, but the audio from this layer is being sent to layer number 2 and being received. Now, if I wanted to make an effects processing node, an effects processing patch, sorry, instead of an aux return, what I could have is audio in. So if I have an audio in the standalone build, you would pick your active input channels, and that would be, your guitar, your guitar input or whatever, your microphone. In fact, I could use my, I guess I could use my microphone. Let's see, but of course I have to. Yeah, maybe not. Maybe that's not a good idea. We'll get some weird feedback and who knows what. But basically, this audio in could be a hardware input from, from your standalone build here, or it could be a sidechain input in your DAW. So if you're using Ableton or Logic or whatever, they usually have a sidechain input option on a track. So you could sidechain another track into Hyperion, and actually quite a few of my, not in this patch set, but quite a few of my patches are just effects patches. Let me just go up a level. Hopefully I'm not showing anything secret. So this patch browser lets you find patches by different categories. So if I wanted to find effects bus patches, I could just click on effects, and it will then just show me all my effects bus related patches. So here's external effects test patch. Oh, it is processing my voice. Can you hear that?
Yeah.
So let's play with this granulator a little bit. Just boost the output level a bit. So yeah, you can hear me going through some crazy echoes. And yeah, we could stick a different effect in there. I don't know, ring mod. See what that sounds like. Hello? 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 Okay, enough of that. So yeah,
that was
you
actually
can,
really cool.
you can basically, you can design any kind of chain you want in here and hook it up however you like. And you can build some mad guitar effects or whatever effects you want and process your other tracks with it.
And you can also use those to process other nodes, right? Other
Right.
other
Yeah,
patches.
so what I would do, instead of audio in, I would go back to aux return, and then my aux return would be another track where I'd have an effects output, and I'd select the correct bus, and then I'd turn up my aux send level, and I would maybe turn down the level of the track. So this trim boost control controls the level for that track, or that, I shouldn't call it a track, it's a layer. So I could have maybe it's best if I don't design a complex patch right now, but I could have a patch going into here, and just turn that up, and what we'll do is just modulate the wave shape here, so we can hear some sonic change. And let's see, something's bound to go wrong when you're live streaming, right?
Of course. All of my streams are just about things going wrong. So.
So why don't I hear anything? Maybe because it's a sine wave. Hang on.
Once I in one of my first.
I turned the volume down. Sorry. So now you can hear that sine wave going into the effects layer, and we could play with it some more by modulating the pitch. There we go. Here's my, so yeah, 24 Hertz is my maximum internal modulation frequency.
So freaky.
Let me just kill that.
One of my first programming jobs, the boss or the manager came to me and said, right when I got the job, and he was saying, he was trying to say a joke, and he came and said, here we have a system where we use the programming system where there are no bugs. We just don't write any bugs. And that's it. I followed that system ever since, and I just had no bugs. It was so easy.
Magic.
I could have just put the bugs in and solved them, but who wants to?
I've just noticed there's some questions in the feed which we didn't answer. Shall we take a quick look? I saw one saying, "Is there anything special you have to do to deal with sustain pedal?"
Oh, I think those are from the previous stream that I
did. That's you. Oh, okay.
Awesome.
Okay, no problem.
Yeah, I know why it kind of combines them.
There is something special you need to do with sustain pedal, actually, with the ARP. I watched a little bit of that stream earlier.
Oh, yeah.
So this ARP actually has a sustain pedal option.
Mm-hmm.
And in this case, what it does is it just holds the arpeggiation going. So when you have an ARP going, just let me turn up the volume a bit. So as soon as you let go of the sustain pedal, it stops the arpeggiator. But in this case, that's really handy to set up an arpeggiation, but play some other notes on top. There you go. That's another patch.
So I know how much you wanna. So the comment is this sounds amazing. Yeah, this is an amazing synth. I know how deeply you want to get into code. Code questions.
That's what this is all about, isn't it? This you've got an audience of potential coders here, so we should definitely talk design and code to some extent.
Yeah, some of them are not so potential. Some of them are very, very, very good coders that are hanging out in these streams, such as yourself, or sometimes we'll see like Jet and Chowdhury and people like that.
I'll do my best not to embarrass myself then, because I'm sure there's a lot of people out there that know a hell of a lot more than me. I feel like what is it? Imposter syndrome. I have this imposter syndrome. I chat with other plugin developers like yourself, and I just feel completely in awe of other people. Like I met Urs Heckman at the NAMM show last summer, and oh my god, this guy, he just blows my mind how good he is and what he knows. I feel so small talking to him.
It's very difficult not to feel the imposter syndrome next to him specifically.
Yeah.
Right?
But many people on the forums that we discuss coding with, I've always felt like I'm just faking it until I make it, basically.
But you did make it.
Yeah, and the way it has happened is because I've done it step by step, one little thing at a time. And like I said, I was very excited the first day that I just managed to get a sine wave out of a buffer and just hear that, that. And I was like, yeah, I got a sine wave. And, it went from there. And every day was, okay, well, what can I do to modulate this? Or how can I change its level? How can I add 2 sine waves? Now how can I get a note from a MIDI keyboard to turn this sine wave on and off? And it just builds and builds. And that's the thing that's made this UI so powerful and this product so powerful. It's just every day I've been adding a little thing to it or tweaking something. And occasionally there have been the big architecture redesigns. Not too many recently, but at the beginning of the product there were some big architecture redesigns that were necessary.
Something that always fascinates me on modular architectures like this is, first of all, one thing that you've already said is you talked about the modulation rate. Right, so there's where you kind of have to decide whether or not you're gonna do the modulation per sample, or you're gonna kind of have some block where between those blocks you calculate the modulation and then you move on with your actual processing for the nodes. And it's so interesting to me that I've seen many solutions for these problems, by the way. One is that I've seen people just do everything audio rate.
Yeah.
And that makes sense, but also it has problems, because when you think about
And that's how I started, actually. I started with audio rate. Everything was audio rate. When I first started doing the work for Intel, it was all audio rate to begin with, and then I tried to add multiple voices and layers, and it just started blowing the CPU up.
Yes. And then also the thing so that was definitely one thing. The other thing I think is fascinating is how you handle stuff like changes in the graph, right? Because you have the user basically coming into your screen and putting their dirty paws on your graph and kind of disconnecting things, connecting things back, and you have all these stuff like filters that keep state. Like how do you handle like all these complicated updates? I think this is a very this is always a problem when I've had to deal with any environment that has definitely even half as much as dynamic change as your plugin.
Right. Well, the node changing thing, when I first started working on this stuff, it was pretty hacky, and it would try and change the node. Basically, it would block the audio thread, which is terrible, and you'd hear a glitch. And the UI would try and add a node to the graph, and it would basically lock the audio thread, which is terrible. So now, the way it works now is that you have this node graph that's being processed continuously in the audio thread at the top priority, of course. And what happens is, if you try and create a node on the graph, like a new oscillator, you drop it in, and what happens is the UI thread creates the instance of the node. It allocates it. I mean, it calls into the core processing code, but from the UI thread. And the core processing code creates the node instance, sets it to all its initial settings, and when it's finished doing that allocation, it basically sets a atomic flag that says it's available. Basically, it's ready. And then the next time the audio processing comes around the loop, it checks that flag, and it says, oh yeah, there's a node or some nodes that need adding to the graph. And just before it starts processing the audio chain all over again, it just inserts that node onto the graph. And the same with audio connections. If you add an audio connection, it will do the audio connection just at the beginning of that loop. And also, every time you add a node onto the graph, every time you make an audio connection, every time you come around that loop, if I change the cables here, and now I reconnect that to here, what's happened immediately at the beginning of the processing loop is that it's actually going in reverse through the audio chain and changing the order of processing of the audio nodes. So it's iterating through the chain, and it's saying, okay, what's above my audio output? Okay, what's connected to that? What's connected to those? And it will reorder my node processing graph so that the nodes are processed in the order that they should be.
So that leads me to the next question. How do you deal with feedback? Is that a thing?
It is a thing. It's not very nice, but it works. You can do it. You can definitely do feedback. Let's solo this part. Let me just turn this granulator. In fact, let me just get rid of the granulator so that we can just hear a bit. And let's get rid of this distortion as well. Okay. And I've got a sine wave. Oh yeah, because I just added that sine tone. Let me delete that node. So a classic classic usage of feedback would be like a what you call one of those reverbs where the pitch goes up. I've forgotten. A shimmer, right? A shimmer reverb.
Mm-hmm.
So we could potentially have a pitch shifting node in the loop here. So I could take the output of the pitch shifter, and you have to be a little bit careful when you do this, So typically you'd probably want a compressor in the feedback loop, maybe even a filter node. But it's definitely not doing any clever stuff. All it's doing is it's basically the pitch shifter is getting the output from the reverb, just a buffer, a block of data, and it's processing it. And the next time around the audio loop, this filter is getting the output of the pitch shifter. So there's a 1 block delay basically, which is not ideal. It's not the way it should be, but it works. You can still get, loops, and because, I have a minimum block size within the synth. Even if you had a massive block size like 1024 samples, it will still only do like maybe 128 sample loop back.
Work with internal block size, not the.
So it won't work with the DAW block size. And even if the DAW block size, if the DAW block size is smaller, it will actually be smaller. But okay, it's not ideal, but here we've just set up a loop, and let's have a quick listen. Hopefully it won't blow up.
Yeah, because I'm guessing you also need to work with the DAW's uneven block sizes, right? Because FL Studio or something could call you with these, like let's say the DAW, the user set the block size.
So there you hear the feedback is sustaining the sound, right?
Mm-hmm.
So that's, so you have to control the amount of feedback by, either using a compressor. So the plugin will crop the audio if it goes too high. You'll get distortion basically.
And if instead of a compressor you'll use, like just a volume.
Actually, the compressor probably wasn't even set to anything right there. Or maybe it was. Maybe it had a threshold, but you could just turn it. You could just delete that and just maybe just turn the volume down a bit, and you test until it's the right level. So in this reverb, you're getting a mix of that pitch shifted feedback plus the output from the filter here. Sorry, you were saying about the block size stuff. So yeah, I'm sure you've encountered this in your own development. When you get variable block size requests, the DAW might actually be set to the audio interface block size, but internally in those buffer requests in the plugin, you could be getting a block of 32 followed by a block of 64 followed by 128, etc. And sometimes it's even worse than that. FL Studio sometimes says, give me a block of 2 samples.
Yep.
Now give me a block of 48 samples. Now give me 73. It's nuts, and the reason it's doing that is because I think it's related to trying to make automation data sample accurate. Or it's just the way it thinks it's most optimum. I don't know why they do it, honestly. But basically within the plugin I have a FIFO that just, builds up the output and spits it out when I've got enough samples to require the required block size.
Okay, so you're adding a bit of, so if the block size is too small, you need to add a bit of delay.
Yeah, but if you get a 1 sample block size request from the plugin, that's not the operating frequency or rate of the audio device, is it? So, actually, the plugin can't really do anything with. The DAW can't really do anything with that data until it gets all of the samples back. So I'm adding a little delay, if that's the case.
But just when you have to report that latency, or you have to.
I do. Yeah, I do report that latency. So sometimes there can be a little latency. Yeah. But that's a compromise. That's the way I've designed it. Maybe it's not optimum. I've not had any complaints. Generally speaking, people keep their hardware block size small enough that the latency is going to be small enough that you won't notice, and nobody's really complaining to me. I did at the beginning of development. I did work with some musicians who were saying, oh, when I have my bass drum sound, it's not quite coming on the beats and it's slightly off. So I did work to minimize those issues, but it's not perfect. But this is one of the compromises I have in order to keep my processing the same. But maybe you could suggest, how would you do it better? How would you handle FL Studio? What do you guys do at Modalix? How do you handle that situation?
So it depends. I mean, we have some plugins that report some latency, like for example, Bitfuzzer that has it has oversampling, right? So you have to use latency to do that. If you choose the oversampling, then you have to have a minimal amount of block size basically for this. So you have to report some amount of latency. It's interesting. I think we usually and there's some things where we do latency, but that's not where the host is not involved with. Like for example, if we do a reverb effect, sometimes we decide that the reverb would have a fixed buffer size, and basically we'll have a pre-delay, right? Basically, you're saying the reverb will have a pre-delay built in, and we're not going to tell the host that, right, or something. So that's
right. I mean, yeah, reverbs. Like I've got reverbs with pre-delays. Not this one in particular, but
yeah.
Like,
but our synth
it's gonna add latency, of course, as soon as you turn up that pre-delay.
Exactly. So we have like for example, we will sometimes have like reverbs with fixed pre-delay for performance reasons, and then they work with their fixed size buffers basically. And that's okay, right? Because we were saying, because the host is not going to compensate for that. To that is just like it's almost like we limited the amount of configuration on that particular reverb, and that's okay. But the problem you're saying that I guess that the issue is if you have a synth that needs a certain block size. That's interesting. Like I mean I would. I know I would have to think of how to do this.
So if the DAW DAW requests a 256 word buffer, say that's what you set for your I/O for your device, for your audio device.
Yeah.
So it's going to request that, and then 256 samples later, you're going to give it the output, right? I mean, it's
So that's what we'll do with the reverb stuff. Like that's
and then if the DAW requests if the I/O is set to the same number. And the DAW requests, a block of 5 samples, then a block of 64, then a block of 28, then etc. until it gets to 256.
Right.
You're effectively, if you just wait and if you build up your own data and then provide that when it's ready at the 256 point, I could be wrong, but isn't that kind of the same as if it just requested 256 samples?
No. Because because you can do this latency free, in a sense, because you can because basically if you're using the FIFO technique, then if you're using the FIFO technique, then basically you're adding more latency than the host is adding, right? The host has buffer, and you're basically adding another buffer on top. And the problem is, like you say, if you can know for sure that the host is always going to ask you, for 256 samples, then you can, you can just do your internal work just like you're doing, and then push the samples at the end of the buffer, right? That makes sense. But because you can do that, that's why we have to use, like, because.
But there's a reason why I don't really want to go to processing blocks at the DAW requests. Like if it says give me 20 samples. Yeah. Internally, I don't want to have to process a block of 20 samples in my filter, for example, because then I have to do my calculations much more often.
Right.
So internally, I want to keep my minimum block size to keep the processing load down. Yeah.
So what I do in this case, I have a templated function that I use for this kind of stuff. So what I'm doing is I have something that divides the block size to some amount, like let's say 64. But then at the end, I do one call for the leftover, if there is any leftover. So for example, if I'm getting 63 samples, right? So I will, and I know this is the size of the full buffer, then I will be doing 63 and then 1, or whatever it is I'll have after that. But then after that, like, I will always try to chop to, like, it basically tries to chop to my preferred size, but only will do one, so if the DAW is giving me a bunch of one sample blocks, which it can, right?
Yeah.
Then I'm basically screwed. But it also means that I have I'm going to process latency free. So that's the down. But it does mean that, and it does mean that if I will get the occasional smaller block size from FL Studio, then there might be a little bit of a spike, but not too bad because it's not all the time, right? So that's really the
I mean, I maybe it's a naive implementation, and I like to keep things simple, just for my own, benefit, so I don't have to worry too much about. I can know that my processing is always going to operate the same way, regardless of what DAW I use, except for this latency issue.
Yeah, the problem is you
but
basically
in terms
need to
of
do
like
the
CPU load, I'm always going to get the same CPU load, and it keeps things simpler for me, at least. Perhaps I need to look into this. This is maybe something I need to think about some more. Up until now, I mean, it's been out for like nearly 3 years, so I don't have any producers saying, "Oh, this sucks. The latency is terrible." Nobody's complaining.
Yeah, I don't think it's going to be. I don't think it's going to be an issue. I think the main question is because basically, if you have a block that's slow enough for the feel of low latency, like for example, if you say it's like 64 samples or something small, then sometimes that kind of latency is not audible. So maybe sometimes that's where it depends. Like for the
and perhaps
for stuff like the reverb, sometimes we've had to use like really big buffer sizes, like 1024, like some big sizes, and that's where you would really hear latency.
Right. And I think it depends on the plugin you're developing. Again, like I said, that this is a modular synth that's been designed to make massive sounds with multiple layers. Many of the sounds I design are kind of spacey or slow or evolving, the textures, and if I was making a bass drum synth or a bass solo bass sound synth, and that was it, and it didn't do anything else, then I would want to optimize for latency for sure. Like if it was a drum synthesizer that had to generate beats that were really precise on the dot, then for sure I would think about that a lot harder. But in practice this is maybe not ideal, but it has worked quite well. There are other things that we can talk about in terms of processing architecture, where I maybe do things in a pretty unconventional way, because maybe it's me being naive, but it appears to work okay. Because we've talked about this before, but basically I use multi-threading, and a lot of people might say, "Oh, that's really bad. You shouldn't do multi-threading in your plugin. Let the DAW handle that. Let the DAW, put the individual synths on individual threads if it wants to." But this was one way that I was able to get multiple voices and multiple layers of modular patches running in a reasonable time.
No, I think multi-threading is good. I think that now with machines that exist, machines now are so good at multi-threading and so relatively bad at single threading, where I think for something like this, like what you're doing, which is almost like a DAW in the complexity of the audio graph, I think you're gonna have to use stuff like threads for the voices.
Yeah.
And I think that
excuse me.
and I think that you definitely want to be able to do stuff like that. Like you want to be able to allow users that have a 16 core machine, which is not rare. It's like any Mac pretty much nowadays
these days
would have something like that, and like you want to be able to help them use their system, especially people who are going to be performing uh, with your synth as the main like processing element, which I think people use, and I think that yeah, like I don't see a problem with that. I know that you know when you think about like I do see sometimes people doing like optimizing with threads where it really doesn't matter. Like let's say your plugin takes 5% CPU and you're trying to lower it to 2% or something by using threads, then maybe you're doing the wrong thing, because then also you're creating problems for your DAW for people who have 20 plugins, right?
Yeah.
But with your case, your patches, you know, can be from 4 nodes to 400 nodes, right, or even more.
I mean, each layer can be 32 voices, so you know, potentially you can have 32 times 16.
Yeah, and how many nodes?
Well, that's the number of notes.
Oh, number.
But then,
not nodes. Nodes. I mean, like processing
and then
nodes.
nodes. So then, you know, each oscillator. Well, there's no limit basically. There is no limit to the number of things you can drop on the graph. There's nothing that's saying, oh, you can only have 5 oscillators. You can have 20 oscillators in your patch, and the oscillators themselves, they're not just simple oscillators. So you've got this unison option here. So for these standard sort of, I call them VA oscillators, you know, you've got up to this unison parameter goes up to 4, but actually internally what it is 2 copies per step. So when you set it to 4, you've actually got 9 oscillators running. So you've got 8 copies of the oscillator that are spread left and right, gradually spread in both pitch and also panning. So with this width control, you've got, you know, the control of how they're spread in the stereo field, and then with this detune control, you've got, I should really make a graphic that shows that actually, because if you look at other synths like Serum, they have a little graphic that pops up that shows like the different oscillators as they're getting spread apart in detuning. And so this detune and this balance control also controls the relative level between the main oscillator, which is in the center, and then the unison copies that are spread gradually in the stereo field. And so you can have 9 oscillators in a single oscillator. So if I set this to 4 and this one also to 4, you know, now we've got 18 oscillators just in these 2 nodes. And then we've got FM, which is each FM node is 4 oscillators because it's a 4-op synth. So you can start, you know, really building up heavy CPU load, and it can get quite crazy. And I have got patches in this synth that have got 16 oscillators, complex oscillators, and they do run okay. And remember we talked about these blue nodes being voice nodes. So how it works with the multiprocessing is that basically each of these voice nodes, what you see on the graph here, each voice is a separate thread basically, which may sound crazy, but
no,
it works.
No, I think this is the correct, but this is a very good way to do this, where you send each voice to a new thread, then they all have to meet the deadline at the end where they mix together, and then you process sequentially, right? And by the way, I think this is very similar to what the DAW would do, in terms of like the DAW would process like different tracks, right, something like that.
Interestingly, I just noticed in Ableton recently, at least on Windows, that, you know, normally most DAWs you would expect them to do a plugin on each thread, right? But I noticed each track. Sorry, I do apologize. A thread on each track or each plugin.
Mm-hmm.
But I noticed in Ableton on Windows, even within one plugin, my own plugin, because I've got some analysis tools that let me log the threads that are being generated by the, you know, I can look at the main audio callback, and I'm noticing the main audio callback is actually being split into different threads.
Yes.
So it'll actually send a buffer request, say 32, 64, 128, whatever it is, you know, how it breaks down the main buffer, and it will split those into separate threads as well. So Ableton itself is actually recombining those blocks into one main buffer, to send it to the device.
That makes sense. And when you think about it, a lot of these, let's call them, like, if you think of the DAW architecture, a lot of them are built in these job queues, where, you know, like in the start of the audio thread, they're gonna they have like some pool of real-time thread, like 16 threads or whatever the DAW is using. Then it's kind of then what usually there's some algorithm there that sends work to the thread that finishes the fastest, right? So for example, I think their idea is that they have some 16 threads, and then they have some algorithm that says, okay, well, who's available for because you might have more than 16 tracks, you might have 50 tracks, and they say, well, who finished first? Okay, you finished, okay, take this job. And sometimes there are all these algorithms that don't even search all the threads. They just go to the first one that like the next one after the last one that was assigned, stuff like that. If you think of there's an algorithm that could say, well, if they're open threads, I'm not going to go back to the previous one to see that it's finished. I'm just going to auto assign to the next one because I don't want to test all of them, right? There's all these algorithms on like just dividing work in arrays. So it makes sense that if a pool of 16 threads open, then you might get your call to your block in like consecutive threads. Like you'll get it from thread 1, then thread 2, then thread 3, or whatever.
Yeah. And that's quite a complex system to manage. And I'm guessing that's why DAWs are so extremely complicated to develop these days. I keep it much simpler. I don't have to think about, oh, this thread just became available, now I can use it in my pool. I basically have a thread pool, and I have a number of tasks. So maybe I've got 8 available threads. I create my thread pool when I initialize my synth. So every time I add a layer, it creates a thread pool based on the number of CPUs that are available. And yeah, I might have 32 voices, but I might not actually be using 32 threads. I only have 8 threads in my thread pool. So basically it just cycles through the voices, and it will do 8 voices, then it will do the next 8 voices, then it will do the next 8 voices, etc. And then it will recombine the mix of those voices in the final audio output node. Actually, these effects bus nodes, they're not multiprocessed, they're just run on the main audio callback thread. But the voices are multiprocessed. So it's relatively simple. I don't have to think about, oh, this thread just became available or not. I just have a pool of threads, and I use them or I don't use them. And if I'm not using them, they're just idling. They're not doing anything.
Yeah. So yeah, Paul, this was awesome. I'm so happy that I could get you on the stream.
Yeah, and I'm really excited by the work you're doing on this. Can we talk about it? Are you allowed to talk about it? The musical generator?
Yeah, sure. It's I've been streaming the stuff I'm doing on it, so it's all pretty public. And
hopefully this can inspire you to get some ideas for that potentially. It's a kind of a similar, and it's not really similar, but there are some similar concepts in terms of the generative patches that I make, how you go about, how you approach, taking one block and generating data and then processing it through another block. There's some aspect of that in Hyperion too, the way I do these generative patches, but nowhere near as advanced as what you're going to be doing. And I'm really looking forward to trying that out when you get to it. What's the timeline on that project, do you know?
It might take a few months. It's quite complicated, so.
It's extremely complex. I think once you go modular, a whole bunch of other problems open up that you weren't expecting. When you have to be flexible like this with a modular synth, there's so many more gotchas that can catch you out. Like the whole graph reconfiguration at runtime. That's something you'll encounter, I'm sure.
Yes.
Pointers will be pointing to things that are no longer there because you just removed them from the graph, or something won't be quite ready when you expect it to be, and it will
Exactly.
crash in a major way. And the trouble with modular graphs like this is sometimes you won't see that except for in a particular race condition, or you may need to implement some clever locking management from in terms of graph building. You need some logic there to make sure something's ready before you say now process it. It's not easy. It's a lot of complexity,
Yeah.
much more so than a standard fixed architecture synthesizer. And I only did this modular synth because that was what I knew, and that was an approach that I'd taken before. But had I started from scratch, and had I not had that experience, I would have definitely wanted to do a fixed architecture synth, and it would have been 100 times easier. Honestly, don't make a modular synth as your first plugin. That's my advice. So yeah. Yes, thank you, Eyal.
Thank
I appreciate you suggesting that we have this chat today. It's been fun, and it's always good to get a little bit of more exposure as well, because I'm a one-man developer, one-man company, and I don't really focus that much on marketing, I have to be honest. I do work with Traction. I just want to give them a shout out. So Traction is my distributing partner. So I realized that I was at the NAMM show in it was in January, or was it? Yeah, it was in January this year. And I got interviewed by Sonic State, and I said, oh yeah, this is all my work. I did everything. I do all of the development, all of the marketing, etc. But actually, I maybe I misspoke slightly, and I want to fix that today. Thank you, Traction. You guys are awesome. You host my product, and you do some marketing for me. They do talk about my plugin, and they have my videos on their website. And yeah, they've been hosting this, and the other plugin I do is called Taya, which is a simplified version of this plugin. It's basically a patch player product where you basically have this interface and you don't see the panels on the side. You just have this, and you can browse patches and select them. And because all the patches have got these macro controls, you still have quite a lot of sonic shaping, but you don't have to think about node architecture. You just basically use the ready built modular patches. But yeah, thanks to Traction for their help with getting this up. And as a one-man company, I didn't know where to start with how to do sales or website hosting. I know you guys have done a great job, and I need to ask you some more about that actually. How you guys managed to set up all of that sales channel for Medallics, how you set up your website. That's something that I really need to learn about. I've got a lot of things to learn, and that's the thing with coding and product development is the more you do it, the more you realize you don't know. So it's definitely good to partner with other people. Something that I have a trouble with sometimes. I try to do everything myself, as you can see, and you got to let go sometimes of some things.
Yeah, I've never learned how to do that. But yeah, I really want to thank you. I think I got to take a little break. I've been streaming for a few hours today, so this is my second stream of the day. I might come back later for another stream, but first I need some, I don't know, get some food or something, get some break.
Definitely.
I see Jesse asking. Oh, by the way, I see David here. Thank you, Paul, for your stream. Said that the advice you gave is solid, and he also said that he got Hyperion as a part of the full Traction suite.
Oh, nice.
So that's so you can thank them for their sales.
Exactly.
Jesse said he came in late, so Jesse, you can watch the stream. It's going to be uploaded in a few minutes to LinkedIn, YouTube, Twitch, etc., and you can see the replay. Basically, we've had Paul Carter, the amazing Paul Carter, here showing his incredible modular Hyperion synthesizer that you can get now. It's an amazing piece of work. We've talked about generative patches. We've talked about doing audio patches. We've talked about how you can use all these modulation schemes and connect different patches from one to another. And we've talked about like how the structure of the of the oscillator modules is, and so many things. So hopefully people watching this back will have a lot of fun, because I think it's it's very unique to talk to a person who's actually built this work from beginning to end.
Everything is hand coded. I will say that I did use some resources online to get some ideas about how to do things like reverbs. And I looked, one website in particular was Nigel Redman for the oscillator side of things. And like I said, I was lucky to work with Matt Teitel when I was at Intel, so thanks, Matt. I learned a hell of a lot from you. And also Roland Rabian, we hired him for a few weeks, and even though he was just there for a few weeks, he did an amazing job. He was so efficient. He's such an efficient coder, so fast. And he helped develop some concepts that I've also learned from in terms of multi-threading, and taken that knowledge forwards into Hyperion. So thanks, Roland. And thanks, Eyal, for the stream today. And it was great to get to know you. We've known each other for what, like 5 or 6 years now?
Yeah.
And I'm always impressed by your amazing energy and enthusiasm. You're an inspiration.
You as well.
Honestly.
So. I see that as well. So yeah, thank you everyone for staying, for watching the stream, and hope you enjoy this when you watch it back. Thank you, Paul, and have a good day.
You too. Take care.
Bye.